6.4, fundamental theorem of calculus.
I was like, why does this look so weird? I just completely forgot to put the A. I was like looking at it, I was like, something looks
Examples.
Examples.
Like something's not right.
Virginia, have you figured out how to do the eraser with like whole lines and whatnot?
Oh, like
the Stacy does it.
I think so. Yeah, object eraser. I just
Erase
like
an entire object.
All right, so part of your fundamental theorem of calculus part 1 is what will allow us to do this. So the find d dx for the integral of negative pi to x of the cosine of t dt. Well, according to the fundamental theorem of calculus, if f is continuous on the interval, then the function f of x equals the integral from a to x of f of t dt has a derivative of every point x in a to b, and df dx is equal to d dx of this, basically, obviously it wasn't that in your notes, but of this, is equal to f of x. So basically, anywhere we see a t, we replace it with x. So this just ends up being the cosine of x.
I think I just heard a sick goose.
Yeah, it did kind of sound like that.
from the computer.
I don't know, but it was
Definitely. If we have d dx of the integral from 0 to x of 1 over 1 plus t squared dt, this is just 1 over 1 plus x squared.
So we just replace t with x,
Yes.
and we take out the dt, and everything else.
Yes. I literally just turned this stupid thing off. Why is it still on? Go away. But now, if you have something like this instead, find dy dx if y equals the integral from 1 to x squared of the cosine of t dt. So what do you notice about this one compared to the other ones?
The other
Or like
ones are-
specifically compared to the top one?
It's find d dx versus find dy dx if y.
What else though?
There's a 1 and an x squared, and there's a negative pi and an x.
So we've got x squared versus x. So this isn't just an x. So the upper limit is x squared, not x. So that means that y is a composite function.
I do not see the word composite anywhere, so what in the world is that?
You don't remember what composite functions are? You got a function and a function. Spent like a whole chapter on this last year.
Can't believe you forgot that.
Y or g composed of f of x.
F of G of H of X.
Okay.
Yes, that. So that means that I need to.
Virginia thought that, like, what was it, 8 minus negative 1 is 7, so I think that's worse than this.
So y equals the integral from 1 to u. So I'm replacing x squared with u because it's a composite function.
So from 1 to me,
Cosine of t dt, where u is equal to x squared.
whoa, grammar. U is equal to x squared, Virginia.
U is x squared.
I is X squared.
I r x squared.
So dy dx is equal to dy du times du dx. So that means that I have d du, the integral from 1 to u of the cosine of t dt, times du dx.
What is this? Chain rule?
Yes.
I love chain rules. Not really, but they're cool-ish. Better than other things. I prefer them others.
So this first part that's in parentheses is just like what we did up here. So this part is just the cosine of u times du dx. Now, what's the derivative of u?
Me.
2x. So this is the cosine of u times 2x. Now I replace down here. So this is actually 2x cosine of x squared.
I think that the du dx is me prime.
So now we can move into some problems with this stuff, which this is the first 20 problems. Holy macaroni, that's a big problem. Okay. We'll worry about that when we get there. It's already 3 o'clock.
Yeah, we spent like.
Well, we did do physics. Okay.
We didn't even talk first.
All right. Y equals the integral from 2 to x
How many
of
lines should this take?
3t plus 2
2.
cosine of t squared dt.
2. Not that number.
So this one just has the x, so it means I just replace t with x. So dy dx equals 3x plus the cosine of x squared.
I feel like they shouldn't be this easy, but I most definitely complained about it. But
6. Y equals the integral from 4 to x of e to the u secant of u du.
me
So what would this one be?
prime.
E to the x secant of x.
Yep. E to the x secant of x.
So we just replace whatever the weird letter is with x, or like whatever's in the integral
Yes.
thing.
Or whatever, yeah, whatever variable's in the integral, which most of the time it's going to be x, but
I don't remember that C.
especially considering these are fine dy dx.
Why are you smiling at me? I'm scared.
I don't know. I was just saying I don't remember that.
Y
C.
equals
Yeah.
the integral from 6 to x squared of the cotangent of 3t dt.
Virginia,
What?
why is your x at the end of secant so small?
Oh, I meant to do it. I can't write today. Nothing's working.
I mean, it's supposed to be
Yes, I am aware.
variable, not like x kind of thing.
All right,
Secant
so
raised to the x.
what do I have here?
A problem. But I just need to know, what would secant raised to the x be? Would that just be like irrelevant?
Secant raised to the
Yeah,
x?
'cause that's what Virginia wrote.
But it'd have to be secant raised to the x of something.
Nah, she just wrote secant raised to the x.
All right, what do I have here?
Oh, the
Composite
Yeah.
nonsense.
Yep. So I'm going to say let u equal x squared. So what does that mean du is?
Squared.
I guess I could say du dx technically.
2x.
Yep. So now I'm going to replace t with u. So the cotangent of 3, well, hold on. Let me rewrite this first before we do this so that we keep this trend. So d du of the integral from 6 to u. This is just so that it's clear what we're doing and we're not just like making stuff up in the in-between, which obviously we weren't, but so we can see it. Of the cotangent of 3t dt times du dx. Now I can take this and replace t with u. Because we're technically, the reason I couldn't do it from here is because I had x squared and you can't just like jump down and do it. So this ends up being the cotangent of 3u times 2x. I replace u with x squared. So this ends up being dy dx equals 2x times the cotangent of 3x squared.
Is this one the same length as the others?
No.
Okay,
Is this
cool.
the long one?
No. Number 16 is the long one that's like a page.
I almost wrote 16.
16 is literally an entire page for me.
Okay, so I have about like a little more than a quarter.
Well,
page
this is
for
the
myself.
problem. So it depends on if you write your fractions all on one line or not.
I do.
Okay, well then it's going to be this one. So 1, 2, 3, 4, 5 lines. If you write them like,
Take up as much space as I want to because I have that whole.
oh,
part of my
okay.
page.
I thought you were debating if you needed to go to another page.
Oh no, I'm saving that space for number 16, which is apparently a scary one in terms of length.
All right, so this problem, obviously you can see that there's u's in the problem, so I can't use u as substitution, so I would choose another letter like
Me.
t or something.
You can pick me.
Just it can't be x, can't be u, because u's already in the problem. So,
That's a number.
notice this here is pi minus x. That's still not an x by itself. And when I take the derivative of pi minus x, what do I get?
Negative pi. Wait. Let me think.
Negative 1.
-1. So if the derivative of this is not 1, then we have to do like essentially like a chain rule. So like up here we did it because it was x squared, so the derivative of that was 2x. But on the other one it was just x, the derivative of that is 1, so I don't need to do it.
So
Okay,
it's
I'm
negative
understanding
x.
that now.
So if it's like negative x, you're going to have to do it.
So if it's not just x, it's a chain.
Yes.
Okay, I understand that now.
It's not necessarily called chain rule, but it's basically what it is for the intent of thinking about it. So,
Now, what I don't understand is how I ended up with just pi minus 1 instead of pi minus x.
so let t equal pi minus x, and we're going to rewrite. So I've got, or no, actually, hold on, let me do this. dt equals -1, since we already discussed that. I guess I should say dt dx, technically.
Okay.
Yeah. All right, so we have d dt times the integral from pi to t of 1 plus sine squared of u over 1 plus cosine squared of u du times dt du, nope, dt dx. This is confusing me because there's a u in the problem and usually it's u substitution.
This time
Why they
it's-
chose to use u when everybody uses u as a substitution variable, I don't know, but it's fine. I'll get over it.
I mean, I guess they just wanted to use u substitution because they were too scared to do it themselves. So they decided
Yeah.
to use u.
All right, so anywhere I see a u, I'm going to replace it with a t. So I've got 1 plus the sine squared of t over 1 plus the cosine squared of t times dt dx, which we already found is -1. So basically just need to throw the negative out front, replace the t with pi minus x. So dy dx equals 1 plus sine squared of pi minus x over 1 plus cosine squared of pi minus x.
Is that all for that one? Yeah, okay.
It's just not very pretty.
Well, it's not ugly either.
Yeah, it's fine.
Could be chapter 5.
All right, 14. See if you paid attention in the last section.
Oh.
Y equals
Oh, I thought
the
there was
integral
I
from
thought there wasn't going to be anything in between 12 and 16. I was trying to flip over my page.
from x to 7 of the square root of 2t to the fourth
Can you move
plus
it up a bit?
t
Thank you.
plus 1 dt.
Oh, thank you.
So what is different about this problem?
Those meanies put the X on the bottom part.
But because we did 6.3 already, we
just
know
flip
what
it
to
over and make it
do.
negative.
Yep, we can flip it. We got to make the whole integral a negative. So this is going to be negative integral from 7 to x of the square root of 2t to the fourth plus t plus 1 dt. Now, this one is just an x, so I don't have to do anything except for replace t. I just got to remember that negative out front.
So they just decided to make that one really easy
Basically, it just is.
to maybe throw us off.
The only reason it's in the harder is because it's flipped. So this is negative square root of 2x to the fourth plus x plus 1.
They just wanted to see if they could throw us off, I guess.
Pretty much. It's like a were you paying attention in the last section. All right, 16. And then there's only one more of these, so if we can at least get through these, it might be like 2 minutes after 3:15, but if y'all are okay with it, we'll just finish those. And then there'll only be a tiny bit of this section that I have to send you a video for. So, anyways. All right, 16. It gets a little dicey here.
Oh, remember those loaded dice that you have?
Yes.
Those were pretty dicey.
Yeah, that's true. All right. Y equals the integral from 5x squared to 25 of t squared minus 2t plus 9.
I'm sorry, that looks like 5.x squared.
That's because there's a fuzzy on there. Over t cubed plus 6 dt. All right, so what's the first problem?
We have to make it negative because of that.
Yep, I've got to make it negative, so this is going to become negative integral from 25 to 5x squared of t squared minus 2t plus 9 over t cubed plus 6 dt. Now what's the next problem that I have?
5x squared. That's definitely not gonna be just 1.
So u is 5x squared. So what is du dx? 10x. So now I'm going to rewrite in terms of u. So this is d du of negative integral 25 to u of t squared minus 2t plus 9 over t cubed plus 6 dt.
So we don't have to put any sort of grouping symbols around the negative integral thing?
No.
Okay. So,
I mean, you can, but you don't have to.
so like, it's understood that it's negative and not just subtracting.
I mean, it should be if you want to put them just because you can. Times du dx. So then now I just replace with u's. So I have negative u squared minus 2u plus 9 over u cubed plus 6 times 10x. And now I replace all the u's with 5x squared. So I have negative, I guess I should say this is dy dx, is negative 5x squared squared minus 2 times 5x squared plus 9 over 5x squared cubed plus 6 all times 10x. So then on top, that's, let's see, negative, and then we've got 25x to the fourth minus 10x squared plus 9 over, is that 125? 5 cubed is 125, right?
Yes.
125x to the sixth plus 6 times 10x. Then I just need to multiply that 10x through on top. So dy dx equals negative 250 x to the fifth minus 100x cubed plus 90x over 125x to the sixth plus 6. And that would be my answer to that one. So not really that hard, it's just a bigger problem, so there's just more involved with it. But the last one of these ones is, oh wait.
I thought that one was gonna take up a whole page.
Well, you do all your fractions on one line. Well, yeah, I showed you what it looked like. Hold on just a second.
Shut up, Virginia.
That's right, that's how we do this one. Okay. 18, y equals the integral from 3x squared to 5x of the ln of 2 plus p squared dp. All right, so if I have an x and an x squared, first of all, they need to be in order. So the bottom one needs to be the x, the top one needs to be the 3x squared. So I need to flip them first. So I need to do negative integral from 5x to 3x squared of the ln of 2 plus p squared dp. Now I actually need to split this integral. So this is going to become d dx, let me think. The negative is going to go out front of it all. The integral from 0 to 3x squared of the ln of 2 plus p squared dp minus, also I should have a parentheses here, the integral from 0, I didn't write an integral, from, oh my gosh, 0 to 5x, I'm struggling, of the ln of 2 plus p squared dp. And then since I used a bracket because of the negative sign, I'm going to bracket that off. So since I have two different variable things that I'm working with, I'm going to use like u and t here. So I'm going to use u for the first one. So u would be what?
6x.
Yep. No.
Oh.
Just replace this first. U to du.
3u squared.
3x squared.
I mean 3x squared.
So then du dx is 6x. And then over here, let t equal 5x. So dt dx is what? And then now I can proceed with this problem. So I've got negative, then I've got d dx of the integral from 0 to u of the ln of 2 plus p squared dp minus the integral from 0 to t of the ln of 2 plus p squared dp. I thought this was going to be a quick problem. I forgot these ones take longer. Oops. But I don't have this one on video, so it's better that we're doing this. The other stuff that's left in this section I should have on video for you. So then we've got the negative out here. I'm just going to keep the bracket. So this becomes what? Just this part.
1 over 2. Wait, are we taking the derivative?
No, we just replace with u.
Oh, ln of 2 plus u squared. Okay.
Yes. Times du dx minus, over here we replace with t. So ln of 2 plus t squared dt dx. So then this is negative, this is the ln of 2 plus, I'm just going to go ahead and write it, 9x to the 4th times 6x minus the ln of 2 times 25, whoops, not 2 times, 2 plus 25x squared times 5. Trying to see how far they actually take this problem. So since this negative is being multiplied by both of these things, they actually do this one first, since it's going to become positive, and since this one's going to become negative by distributing that negative, they just rewrite the order. So this is going to become dy dx, that I've been failing to write the whole time, is equal to 5 ln of 2 plus 25x squared minus 6x ln of 2 plus 9x to the 4th. And that whole thing would be my answer there then. So up to where we are right now, 3, 9, hold on, trying to make sure I have ones that are good. 13, 15, and 19. And then the rest of this stuff, there must be a chunk of my stuff that's missing here. I'm going to have to figure that out and make sure I have a video that goes with the stuff that's missing. Because my notes are missing a huge chunk in this middle part, apparently. Like 21 through 40 is all missing. I'll figure it out.